Welcome to Chemistry Online. Today we're going to talk about significant figures, what they are, and how to use them in calculations. In chemistry, we're going to work with lots of quantities that are measured. In order to express the accuracy of that measurement, we use a concept called significant figures. For example, if I gave you this ruler and I asked where the red arrow was pointing, you'd look and say, well, it's above 54 and it's less than 55. It's about 54.5. Now, if I had said it was 54, obviously that's not right because it's more than that. If I said it was something like 54.666 whatever, that would be wrong also because you can't tell that. It's somewhere between 54 and 55. We say that this number is good to three significant figures. Our last digit is our best guess, and that is the least significant digit. When you're looking at a number and you're trying to decide how many significant figures it has, first thing you need to do is to decide if the number has a decimal point or not. If it does have a decimal point, remember, leading zeros are never significant, trailing zeros are always significant, and of course zeros between non-zero digits are always significant also. If we don't have a decimal point, trailing zeros are never significant. Again, in all numbers, if zeros appear between non-zero digits, they are always significant. Let's look at an example. If we have 3,400, first thing we say is there is no decimal point. Therefore, our trailing zeros are not significant, and we're left with two significant digits. Here we have a number with a decimal point. Our leading zeros are not going to be significant. Our trailing zero, however, is, and again we have two significant figures. We have a decimal point. Our leading zeros are not significant. The zero is between non-zero digits is significant, giving us three significant figures. If I gave you a number in scientific notation, 6.02 times 10 to the 23rd, this really represents a number that looks like this. Again, there's no decimal point indicated. All of our trailing zeros disappear, and we're left with three significant figures. Whenever you have a number shown in scientific notation, all of the digits that are shown in the coefficient are significant, and of course the powers of 10 are not. Do some quick examples here. If we have 0.0257, we have a decimal point, our leading zeros are not significant, we have three significant figures. Our next number, we do have a decimal point, we have four significant figures. In scientific notation, we would show all of them like this. 93 million, no decimal point, our trailing zeros go away, we're left with two significant figures, 9.3 times 10 to the 7th. Our next number, well, it doesn't matter if it's positive or negative, the same rule. We do have a decimal point, so all of our trailing zeros are significant. We would write this in scientific notation as minus 6.58000 times 10 to the 4th. And finally, our last example. We have a decimal point, but none of our leading zeros are significant, so we have 2.78 times 10 to the minus 6. Now, once you know how many significant figures your number has, we're going to use these often in simple calculation. There are two rules, one for addition and subtraction, and one for multiplication and division. In addition and subtraction, you don't really look at the number of significant figures in each of the numbers. You look to see which of the numbers has the fewest number of digits after the decimal point. For multiplication and division, you simply look at the fewest number of significant figures in any number in the calculation. So for example, if we have 1.455 and we're adding it to 3.2, we have 3 digits after our decimal point in our first number, but only 1 in our second. Therefore, we must round this answer to 4.7. Here we have 2 digits after the decimal point in both numbers. We only have 2 significant figures in our second number, but when we add these, we're left with 1.61, 2 digits after the decimal place, and a total of 3 significant figures. For multiplication here, we have 2 significant figures in our second number, 3 in our first. That's our calculator answer. We must round this to 2 significant figures. Here we're doing a compound operation. If we take and simply do our calculator, we would wind up with a number like this. In our numerator, we have 4 significant figures multiplied by 1,000 with 1 significant figure, 3 in our denominator, so we must round this to 1 significant figure. In a combined operation like this, we would do our calculator answer. Then we would look at our numerator, where we're doing simple subtraction. We have 3 digits after the decimal point in both numbers, so our numerator is 5.022. That's 4 significant figures. Our denominator, where we're doing division, has 5 significant figures, so we must round this to 4 significant figures. When you're doing a mixed calculation like this, you want to do addition and subtraction first, figure out how many significant figures you're working with, and then do multiplication and division.